Okay, so let's quickly look at the gradient of a curve. The gradient of a curve, okay? So let's assume you're given something like this. You have a curve like this. This is the y-axis. This is the x-axis, okay? Let's assume you have the 0, 5, 10, 5, 10, okay? And you have to look for the gradient of this curve. Let's assume this is P, Q. Now what you just need to do is to draw a straight line that touches this particular curve at a particular point. This straight line that touches the curve at a particular point is called a tangent. So the gradient of this curve PQ is the same thing as the gradient of this tangent. Okay? So what do? We look for the two nearest, okay? Just pick any two lines on both the x-axis, trace it to the y-axis. Okay? Another one, trace it around here. Okay? So this first one is going to be our x1 approximating to y1 and x2 approximating to y2. So if you're asked to look for the gradient of this curve, draw any tangent, then look for the gradient of the tangent. So generally, the gradient of a curve, okay, is also known as the slope. And we denote that as m. Okay. Any 2 points on the y-axis, that's y2 minus y1 over x2 over x1. All right. So y2, this is 10. Let's assume this is around 8. Okay. 8 minus y1, let's say this is 4. Divided by x2, well, let's say this is around 9 minus x1, let's say this is around 3. So we're going to have something like 4 divided by 6. So the gradient of that curve is what? 2 divided by 3. Like I said, the gradient of the curve is also known as what? The slope of that curve. And the slope or the gradient of that curve is the same thing as what? The slope or the gradient of the tangent. A tangent is any straight line drawn to meet a particular point on a curve. So for the gradient of the curve, you'll be given two values, or you can find it yourself depending on how this question is being structured. On the y-axis, look for the two numbers. On the x-axis, look for the two numbers. Then divide and get an answer. As simple as that. This is very important because during the later stages of the course, we'll be looking at the normal of limits, tangents, and all that. But this is just the introductory aspect, the gradient of a curve. Thank you. Okay, so let's assume we have given this question. Find the gradient of the curve y equals 3x to the power 4 minus 2x to the power 2 minus 5x minus 2 at the point 0, minus 2 and 1, 4. Okay, let's assume we have something like this. Okay, so answer. Gradients. Whenever you hear gradients, we are talking about slope. And slope means what? Dy dx. So if the y is given as 3x to the power 4 minus this, so the first thing you need to do is to look for your dy dx. Okay, and I told you that this is what Leibniz notation from the last class. Okay, Leibniz notation. You can also write it as what? Y prime x. Okay, still the same thing. Y prime x, that's the functional notation. Okay, so dy dx here is what? 12x to the power 3 minus 4x minus 5. So the first point, so you're going to say at point 0 minus 2. No, this is x, this is y. So anyway, you see x, you put what? 0. So at point 0, minus 2, our dy dx is going to give us what? 12 into 0 to the power 3 minus 4, this minus 5. Final answer minus 5. Okay. And also at point 1, 4. This is x, this is what? Y. X2, Y2. So divide the x is going to give us 12, 1 to 3, minus 4, 1, minus 5. This gives us 12 minus 4 minus 5. That's what? 12 minus 9. That gives us 3. So the gradient of that curve at the point that is what? Minus 5 and 3. Minus 5 and 3. Okay, so another example is determine the coordinates of the points on the graph y equals 3x squared minus 7x plus 2, where the gradient is minus 1. Okay, so for a question like this, what you need to do is just determine the coordinates of the points on this where the gradient. So the gradient is given already, and I told you that the gradient means what? Slope. Slope means dy dx. So our function is already given as 3x squared minus 7x plus 2. So the gradient is going to give us what? 6x minus 7. And the gradient is given as what? Minus 1 already. So that means our dy dx is minus 1. So minus 1 equals to 6x minus 7. So we're going to have, if we bring 6x here, it becomes minus 6x equals to minus 7 plus 1. So x equals to 1. Okay? Minus 6x equals to minus 6. Divided by minus 6. Okay? So x is what? 1. X is 1. So if x is 1, therefore y equals to 3. This is the function originally given. So anyway, you see x puts 1. Minus 7, 1 plus 2. So that will give us 3 minus 7 plus 2. Minus 7 plus 2, that's minus 5. 3 minus 5 minus 2. So y equals to this. So the coordinate of the point on that graph is what? Minus 2. Okay, so the coordinates, so I say hence the gradient is minus 1 at the point 1, minus 2. Thank you. Okay, so you're welcome back. So today we're going to be looking at L'Hopital's rule. So please, if this is your first time of joining us, kindly like, comment, and share. We would really appreciate that. Okay. So L'Hopital's rule just means that we are trying to differentiate both the numerator and the denominator. So whenever you have a function like this, you are asked to look for the limit. Two functions, the numerator divided by the denominator, and on application or direct substitution of the constant, you're having 0 over 0 or infinity over infinity. That means it is what? Indeterminate. So what do? What we just do is we differentiate, or we find the derivative of both the numerator and the denominator. Then we substitute. Even after substitution, you are still getting 0 over 0 or infinity over infinity. You have to differentiate again. You keep on finding the derivative until you have a definite value as your final answer. So that is what L'Hopital's rule is all about. In some tests, they refer to it as Bernoulli's rule. Bernoulli's rule. So still the same thing, Bernoulli's rule. Okay, but generally we call it L'Hopital's rule. L'Hopital's rule. So let's look at some example. Example 1, we're asked to look for the limit as x tends to 0 or x approaches 0 of 2x squared over cos x minus 1. So if we apply this directly, anywhere you see x, put 0. 2 times 0 is 0 already. Cos 0, 1. 1 minus 1 is 0, 0 over 0. So that is not the correct answer. So we have to apply what we call it the Bernoulli's rule or the L'Hopital's rule. So for this question, applying L'Hopital's rule, if you differentiate 2x squared, you have 4x, okay? 2x, 2 times 2, 4x, x, remove 1 from the power. Then divided by, if you differentiate cos x, you don't always have minus sin x. Okay, so minus 1, minus 1. Okay, so if you differentiate minus 1, you have 0. 0. Because 1 is a what? Is a constant, so 0. So on direct substitution, 4 times 0, still 0. Sin 0 is what? 0. So 0 by 0. So that means we have to what? We have to differentiate again. So we find the second derivative. If we differentiate 4x, you have what? 4. Differentiate sin x, you have what? Cos x. This negative sign is still there. Okay? So 4 over minus cos x. On direct substitution, we don't have x here anymore. We have x here. Cos 0 is what? 1. Minus 4 over what? 1. The final answer minus 4. So this is a what? A determinate value or a determinate answer. Unlike the first derivative. Okay? So that's what all L'Hopital's rule is about. Once again, you have a question on direct substitution. You have 0 over 0 or infinity over infinity. That is what? Indeterminate. What we do is we have to differentiate, find the first derivative of the numerator and the denominator, then you substitute. Even after substitution, you are still having an indeterminate value. You have to keep on finding the next derivative until after the substitution you have a determinable value or a definite value. So let's look at more examples. So we have x squared minus 16. Example 2, lim x tends to 4 x squared minus 16 over x minus 4. So the same way, if you look at this question, by direct substitution, 4 squared minus 16, that's 16 minus 16 is 0. 4 minus 4, that's 0, 0 over 0, indeterminate. So we have to apply L'Hopital's rule. Okay, so the same step, you always have to tell us, applying L'Hopital's rule. Applying L'Hopital's rule. Differentiate x squared, you have what? 2x minus 16 is a constant, goes. Differentiate x1, that's 2x. Final answer, lim x tends to 4 of 2x. Anyway, see x, we put 4. 2 times 4, that's 8. Okay. Okay, so looking at more examples, we have lim as x tends to 0 of sine x over x. Okay, so the same thing. If we directly substitute 0 for x, sine 0 gives you 0, 0 by 0, indeterminate. So what do? You apply L'Hopital's rule. Okay, applying L'Hopital's rule. Differentiate the numerator and the denominator. Differentiate sine x, you have cos x. Differentiate x, you have 1. Okay, so that gives lim as x tends to 0 of cos x. So final answer, cos 0. And cos 0 is what? 1. Again, number 4, we have lim 5t4 minus 4t squared minus 1 over 10 minus t minus 9t cube as t tends to 1. Okay, so for this, on direct substitution also, 5 minus 4, 1 minus 1 is 0. 10 minus 1, 9 minus 1 is 0. Okay, 0 by 0, indeterminate. So we have to what? Apply L'Hopital's rules. The same thing. Okay. So differentiate the numerator. We have 20t raised to the power 3 minus 2 times 4, 8t minus 1 is a constant. It goes out is a constant. Minus 1 minus 3 times 9. That's 27. 27t squared. All right. So if you find the limit of this as t tends to 1, anyway, t you put 1. So we're going to be left with 20 minus 8 over minus 1 minus 27. That gives 12 over minus 29. So the final answer is what? This 28. And the final answer is 4 here 3, 4 here 7. So minus 3 divided by 7. Then another example is if you have something like number 5, lim x tends to infinity of exponential x over s squared. So what do we do here? On direct substitution, infinity over infinity. Okay, that's indeterminate. Okay, so what do we do? Differentiate up and down. Okay, numerator and denominator. Differentiate exponential x still give us exponential x. Okay, by the time you start with differentiation, you understand those ones better. Differentiate s squared, you have 2x. Okay, so the same thing, still going to give us exponential over infinity over infinity. All right, so this can easily give us, if you differentiate again, see exponential x over 2. All right, so final answer what? Infinity. So if you differentiate this, if you find the limits of this, the final answer is going to be infinity. Let's look at this last one. Lim cos x over pi over 2 minus x as s tends to pi over 2. Okay, so what do we do here? Pi over 2, that means 1 over 2 over 2, that's 90. Cos 90, 0. Okay, 0. So 0 over pi over 2, 0 over that's indeterminate. So we differentiate numerator and denominator. So we're going to have, differentiate cos x, you have what? Minus sine x. Okay, if you differentiate that, this is a constant. Differentiate minus x, you have minus 1. So that's minus sine x. All right. Lim of x tends to what? Pi over 2 of minus sine x. All right. So if you substitute pi over 2 for x, you're going to have minus sine pi over 2. You know, pi over 2, 90, minus sine 90. Okay, and that's going to give us what? Sine 90 is 1. Okay, so minus 1. Sine 90. So sine 90 is minus 1, minus 1, minus 1. You have plus 1 because of this minus here. Okay, sine 90. This is minus 1. Okay, minus 1, that's plus sine x, plus sine x, plus sine x, plus 1. So plus 1. So in summary, for L'Hopital's rule, differentiate numerator, differentiate denominator until you have a particular value on direct substitution. All right, so thank you. So good day, guys. So thanks for joining this channel. If this is your first time of joining this channel, please kindly like, comment, and share. Okay, thank you. So today we're going to be looking at differentiation. Okay, differentiation. Now, differentiation is just one of the topics we have under calculus. Differentiation is also known as differential calculus. So under this differentiation, we're looking at some of the ways that we solve differential questions. Okay, first of all, we're looking at the first principle. First principle of differentiation. Take a look at the product rule of differentiation. Okay, then we go ahead to talk about the quotient rule of differentiation, then talk about the chain rule of differentiation, also known as the function of a function rule. Then we can now look at differentiation of implicit functions, implicit functions, differentiation of hyperbolic functions, and all that. Okay, hyperbolic functions, But generally, we start with looking at this 4. Okay, then if time permits us, we can also touch the others. So we're going to start with the first one, which is the first principle method of differentiation. The first principle method of differentiation. The first principle method of differentiation. Okay. So the first principle method. Now this method just states that for every change in y, there is an equal change in x. That is, as y is increasing, x is also increasing. So for example, we are asked to differentiate y equals to x from the first principle. So what do? Y becomes y plus delta y equals to x plus delta x. Okay, so if you make your delta y your subject of the formula, you have delta y equals to x plus delta x minus y. Delta y equals to x plus delta x minus, what's our y originally from the question? X. X minus x, delta y equals to delta x. The next step is to divide both sides by delta x. So delta y over delta x is equals to delta x divided by delta x. So we now have delta y over delta x equals to 1. The next step is to now look for your limits. So you find lim as s tends to what? 0 of delta y delta x equals to 1. And after taking your limits, this delta becomes d dy dx equals to 1. This means that anywhere you see delta x, put 0. As delta x is 0, anywhere you see delta x on the right hand side, put 0. But fortunately for us in this question, we don't have a function of delta x. So that still remains 1. So this, anytime we differentiate x, we'd always have 1. For exam purpose, we need to quickly, verify or to ascertain that what we have worked out is actually correct. So we use the direct method of differentiation, which says that if y equals to x raised power n dy dx equals to, bring n down, n times this n, x, remove 1 from the power. Okay, so for that question, x raised power 1, 1 times 1, 1, x raised power 1 minus 1, 0, x raised power 0 is what? 1. So that means we are correct. Thank you. Now let's quickly look at the second example. Number 2, second example. Differentiate y equals to s squared from the first principle. So as y is changing, x is also changing. Can you see what I've done? X plus delta x, then the square is going to be outside the bracket, not inside the bracket, outside the bracket. The next thing is to what? Make delta y the subject of formula. So delta y equals to, if you expand this, you have x squared plus 2x delta x plus delta x all squared minus y. And what's our y originally? X squared. collect like terms. S squared cancel S squared. So we are left with delta y equals to 2x delta x plus delta x all squared. What's the next step? Divide. Good. Divide both sides by delta x. So we have something like delta y over delta x equals to 2x delta x over delta x plus delta x all squared divided by delta x. Okay, so delta x cancels delta x. One of this cancels one of this. Okay, so we are left with what? 2x plus delta x. So the next thing is what? Taking limits. Taking limits as delta x tends to 0. So after taking limit, this becomes what? D. dy dx. And anyway, you see delta x on the right hand side, you put what? 0. So final answer 2x. So for you to quickly verify or ascertain, so s squared, differentiate s squared, 2 times 1, 2x, remove 1 from the power, 1. So that means we are correct. Thank you. Okay guys, so let's assume we are now given the next question to differentiate from the first principle. Differentiate y equals to x cubed plus 2x plus 5 from the first principle. So what do we do? As y is changing, x is also changing. X plus delta x cubed plus 2x plus delta x plus 5. 5 is a constant, okay? It must appear. So y plus delta x, if you expand this using binomials theorem, okay, we're going to have something like s cubed plus s squared delta x plus x delta x. This will be 3, okay, from binomials rule. This will be 3 delta x squared plus delta x cubed. All right. You need to quickly revise your binomials theorem, okay, if you've forgotten this. That's another subtopic on its own, okay? Under binomial expansion, okay? Or Pascal. You can even use Pascal triangle, okay? So if you expand this, you have this. Then plus this 2 times x, 2s, 2 times delta x, 2 delta x, and plus 5. So what's the next thing? Make delta x your subject of the formula. So delta x is still going to give us the same thing, okay? S cubed plus 3s squared delta x plus 3x delta x squared plus delta x cubed plus 2x plus 2 delta x plus 5, then minus y. Minus y, okay? Minus y. And what's our y originally? S cubed plus 2x plus 5. So minus we multiply all this, right? So s cubed plus 3s squared delta x plus 3s delta x squared plus delta s cubed plus 2x plus 2 delta x plus 5 minus s cubed minus 2x plus 5. Sorry, minus sign plus is also minus. Okay. Now, collecting like terms. Please, you must always write this. If it's a theoretical question, you must always highlight what you're doing. Okay. So next thing is what? Collecting like terms. So s cubed minus s cubed. Cancel out. Plus 2x minus 2x. Cancel out. Plus 5 minus 5. Cancel out. So delta x equals to 3s squared delta x plus 3x delta s squared plus delta s cubed plus 2 delta x. So what's the next step? Divide both sides by what? So this is still delta y. Oh, sorry, this is delta y plus delta y. Sorry, y plus delta y. Y plus delta y. Okay. So the next step is what? Divide both sides by what? Delta x. Divide both sides by delta x. So delta y over delta x. Each of this will be divided by delta x, divided by delta x, then delta x. Okay. This cancels this. One of these cancel one of this. Okay. This cancel one of this. This cancels this. So we'll be left with 3s squared plus 3x delta x. Remember, this is 2 of delta x. One has cancelled out the other one, so we're left with just 1 plus one of this cancel 1. We're left with 2 delta x squared. Okay. So what's the next thing to do is what? Taking limits as delta x tends to 0. So after taking limits, remember it becomes your delta y over delta x equals to 3x. Anyway, you see delta x, just put 0. 3x times 0, 0. 0 squared, 0. Final answer, 3s squared. Then plus, there's a 2 delta x here. Sorry, there's a 2 delta x here. Okay, plus 2. There's a 2 here, please. 2. Very important. 2. There's a 2 there. So that's it. So verify. 3 times 1, 3x. Remove 1 from this, 2. 3x squared. 2x, 1 times 2, 2. Remove 1 from this, 2. This is a constant. If you differentiate the constant, you have 0. So that means we are correct. Okay? So very simple. First principle method is very simple. For theoretical questions, if you're asked to differentiate using the first principle, you must follow the steps. As y is changing, x is changing. Collect like times. Divide both sides by delta x. Then take your limits. Then verify. Always verify, okay? Always be sure that your final answer is the correct answer using that direct method, okay? So thank you. So that's all about the first principle method. The first principle method. For advanced classes, you may even be given x raised to power 4. Okay? You can be given x raised to power anything. If your lecturer is very not wicked, let me say wicked, but if it's someone that wants, to stress you, you can give x raised to power 6. Yes. As far as you know your Pascal very well, your binomial expansion, okay? For example, remember your Pascal triangle? 1, 1, 2, 1, 1, 3, 2 plus 2, 1 plus 2, 3, 2 plus 1, 3. 1 always starts it, 1 always ends it. 1, 1, 1, 1, something like that. 1, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1 plus 4, 4 plus 6. 6 plus 4, 4 plus 1. 1 plus 5, 5 plus 10, 10 plus 10, 10 plus 5, 5 plus 1. So, and so on and so forth. So, if your x is raised to power 6, for example, this is raised to power 1, this is power 2, this is power 3, this is power 4, this is power 5, this is power 6. So, let's assume you have something like x plus delta, x is power 6. So this is going to be the coefficient of your what? Of your expansions. So it's going to be what? X is power, this is 1. So just like, you pick one of them, 1, multiply by the first thing we have here is x. This power what? 6. Multiply by delta x. This power what? 0. Plus what's the next coefficient? 6. Multiply by x. This power. Then this is 6 here, but it's going to be decreasing. This power what? 5. delta x raised to power, and this one is decreasing, this one is what? Increasing. Good. You're getting it. Yes, plus, what's the next coefficient? 15. Multiplied by x raised to power what? 5 here is going to be what? 4 here. And this one is decreasing, that one is what? Increasing. So delta x raised to power what? 2. But remember, you have to always do this for delta x, because that square is not affecting just x alone. The function is delta x. X cannot stand alone. So that square does not affect only this x alone. Please always take note of that. Okay. Then plus, what's the next coefficient? 20 multiplied by x raised to power 3 delta x raised to power 3. Okay. Plus, what's the next coefficient? 15 x raised to power what? 2 delta x raised to power what? 4 plus 6 x raised to power 1 delta x raised to power what? 5. Then plus the last one x raised to power what? 0 delta x raised to power what? 6. The way to know you're correct is just that anytime you add the powers together, they must always give you what you have here. 6 plus 0, 6. 5 plus 1, 6. 4 plus 2, 6. 3 plus 3, 6. 2 plus 4, 6. 1 plus 5, 6. 0 plus 6, 6. So that's how to expand. Very simple. So once you understand this Pascal very well, you know how to expand. No matter the raised power you're given for your first principle method, if you ask to use the first principle method, you will be able to do that without any stress. Okay, so that's what first principle is all about. As y is increasing, s is also increasing. Now another thing to quickly explain is just that, remember the first one I was using this symbol, while the subsequent I was using this symbol. You can use anyone you're comfortable with. Most text they use this. This is just what? Delta, the small capital of delta. This is what the capital letter of delta. So just like writing capital letter y, small letter y. This small letter delta, capital letter delta. You can use anyone. But please, anytime you take limit, it must always be d, your normal d. After taking limit, it must always be this. Another thing is just that this is called what? It's called the Leibniz notation. Leibniz notation, okay? There's another one we call functional notation. Functional notation. For functional notation, okay, we prefer to write as f prime x. F prime x means what? The f ds, that is the function with respect to x. So if that function is, let's say y equals to 2s plus 1. So I'm going to say y prime x equals to, if I differentiate this, I'll have 2. So this is what? Functional notation. That is, I have differentiated y with respect to x. The function here is what? Y. So this one is called what? Functional notation. Okay, while this one is called Leibniz notation. Okay, so it's very simple. So please, if you have any question, drop it down in the comment section. Feel free to ask. Snap your class notes, snap your personal notes if you have any question or any verification or any subtraction or addition. This is an era where we all have to be knowledgeable. Mathematics is very simple, especially when it comes to calculus. You cannot afford to not understand what calculus is all about. And this is just the introductory aspect. So please, if you have